All right, we'll next talk about a Fisher's exact test, similar to a chi-squared. It's a statistical hypothesis test used to assess the association between, it says two, but in fact could be more, binary variables in a contingency table. So it could be a 2 by 2, 2 by 3 again. Particularly useful when working with small-sized samples or small cells particularly. It's a non-parametric test. Again, so you're not using this for continuous data, you're using it for categorical data. It assumes no distribution in the data, and it's similar again to the chi-squared test for independence. Some assumptions, and when you're thinking about statistical tests, we talk about assumptions, and that relates to the underlying distribution of your data. So assumptions for Fisher's exact test, the variables are categorical and binary, although you really can do a 2 by 3 as well, meaning that they can take one of two values. So a 2 by 2 contingency table can be populated. They come from independent samples, so not related samples. It's not like a pre-post, for instance, in a person. And then one or more of your cell value counts in the contingency table is small, less than 5. When you're initially looking at data and you develop those 2 by 2 tables or 2 by 3 tables, you'll see what those counts look like, and you'll get a warning if you've got cell counts less than 5, which will be I need to use a Fisher's exact rather than a chi-squared test. And here's an example from a paper published in 2024 on risk factors for pediatric facial trauma in an Appalachian region, so an epidemiologic review at a single institution. And this is a table of multiple tables in the paper looking at the mechanism of injury, comparing urban and rural to see if there might be a difference. The p-value here is from a Fisher's exact because, as you note, we've got some small numbers at the bottom of the table. You'll see the actual values of 5, 5, 3, and 8. When you get warnings, you'll see that it's the expected, actually, not the actual value less than 5 if you get a warning for not using a chi-square and choosing a Fisher's exact instead.